This is Lawrence Krauss, and he's going to admit that saying you cannot go faster than the speed of light is a lie. So I'll play you this clip.
But it turns out when we say that you cannot travel faster than the speed of light, we're lying. We have to be a little more careful. You cannot travel through space faster than the speed of light. But space can do whatever the hell it wants. And space can expand at far distances faster than the speed of light. So if you could manipulate space, with general relativity, you could be standing still and still moving at the same time. We're doing that right now. We're standing still relative to each other. But relative to an audience in a university on a planet around a star at the other end of the visible universe, we're moving away at the speed of light. And that audience in that theater, in that planet around that galaxy, they're also at rest. So they're at rest and we're at rest, but we're moving away at the speed of light. Why? Because the space between us is expanding so fast. So if you can manipulate space, in principle, you can imagine traveling faster than light. And this is the idea, it's quite simple. So you want to get from here to the nearest star. It takes 100,000 years for a rocket to do it, let's say, or with conventional rocket. Voyager will take that long to get to the nearest star. But all you have to do, if you can manipulate space, is to arrange for the space between you and the star to collapse in a fraction of a second, and the space between you and the Earth to expand in a fraction of a second. And then you're there you didn't move, but the space did all the work, and now you're near the star and you're four.
Okay, so in theory, you can move faster than the speed of light. So earlier he was dealing with a question, and he seemed to be dealing with it from the context of special relativity, and so we'll go to that now. So this person is going to ask a question about are extraterrestrials here, and Lawrence Krauss here is going to answer seemingly from the context of special relativity. So let's get into this question.
Mr. Krauss, what do you think about our possible encounter with extraterrestrial civilization? Is it dangerous for us? Like, for example, Stephen Hawking said about that it can be like...
Well, Stephen said lots of things. Yeah. Look, the likelihood of ever interacting with an extraterrestrial civilization is small, even if they exist. First of all, we don't know. We may be alone in the universe. We don't know. We don't know what the probability of life. We don't yet know how life forms here on Earth. We have ideas about what processes led to the development of life, and then we don't even know what the likelihood that intelligent life forms is. So it could be very, very rare. But even so, the universe is very large. Even our galaxy is very large. And I once worked out in one of my books the likelihood of detecting life in our galaxy, even if it exists, intelligent life, is still very remote. So I'm not worried, first of all. I think it's highly unlikely. But even if we did detect it, I think I disagree with Stephen and other people who are worried about this. Because I think the highest likelihood is detecting, if you could detect a civilization that was intelligent, it would probably have been technological much longer than us. Which means that it would not be interested in us at all. I mean, we wouldn't be a threat. Moreover, who the hell cares? Because they're not going to come visit us. We may find out about extraterrestrials, but they're not sending spacecraft to us. We just can't send spacecraft throughout the galaxy at anywhere near the speed of light. It's just impossible. Okay, and so...
So there you go. He's saying it's impossible to go at the speed of light, and presumably that's from the context of special relativity. So he's trying to say that, well, trying to imply that we can't do it, and so the aliens wouldn't be able to do it as well. He's going into a lot more details about other things as well, but that's basically it. He seems to be talking from special relativity, that you cannot go at the speed of light. So we go on to this one, and this later on he has a question from this person about warp drives, and so suddenly he has to abandon that bit about, oh, you can't go at the speed of light. You can go faster than the speed of light from theory based upon warp drives. So let's get to the question from him, and to him admitting he was lying about you can't go faster than the speed of light.
Institute of Physics and Technology from KPI. I want to ask you a question about the warp engines and Alcubierre engines. In previous 30 years there was a bunch of theories about this kind of stuff, and I want to ask you a question. How do you think can we achieve some results in this in following years, or maybe in this century?
Sure, I wrote about that many years ago in the Physics of Star Trek book that I wrote. The idea is, you've heard of Star Trek, right? Okay. So the problem with science fiction, well, it's not the problem. The problem with real life is that we can't travel faster than the speed of light, and the galaxy's big. So we're 30,000 light years from the center of the galaxy, and therefore if we want to explore the galaxy, take 30,000 years to get there. That does not make for exciting television. 30,000 years is a long time. So they had to come up with something that allowed you to go through the galaxy faster than the speed of light. They called it warp drive. And it was easy for the writers, but it's not so easy in the real world. But it turns out, when we say that you cannot travel faster than the speed of light, we're lying. We have to be a little more careful. You cannot travel through space faster than the speed of light. But space can do whatever the hell it wants. And space can expand at far distances faster than the speed of light. So if you could manipulate space, with general relativity, you could be standing still and still moving at the same time. We're doing that right now. We're standing still relative.
So there you go. He's admitting saying you cannot go faster than the speed of light is a lie. In theory, you can go faster than the speed of light in the context of general relativity. And earlier he seems to have been talking about it in the context of special relativity. So you've got this confusion happening between special relativity and general relativity. One minute you're saying you can't go at light speed, and next minute, oh, you can go at light speed. So it's a confusion between the two theories here, and they like to hide things in that sort of way. Now he's talking about general relativity, I think, and he's trying to say in theory it's possible to go faster than the speed of light. As he carries on with this talk, he's going to try to come up with excuses where it might be impossible to do it in practice. But what we can do now with our level of technology, we can't go faster than the speed of light, but maybe an alien civilization could go faster than the speed of light with more advanced technology. It's just a question of, in theory, it is possible to go faster than the speed of light. Now, what he says about general relativity, I don't really want to agree with. In general relativity, what you're dealing with is warp space-time, and this is a two-dimensional representation, and some people argue that that's not a very good representation because what you're really talking about is four-dimensional. But sort of these objects, say that's supposed to be the sun and that's the earth, and that their motion is due to warp space-time. Well, in the context of Newtonian physics, it's forces and not this warp space-time. So it seems to be two different representations of how you're dealing with gravity. In Newtonian physics, there's no problem with going faster than the speed of light in theory, and he seems to be saying in the context of general relativity with all this sort of stuff, oh, in theory it is possible to go faster than the speed of light. So it's both theories, Newton and Einstein, are agreeing upon that sort of thing in that kind of context. So there you go. When people say you can't go faster than the speed of light, in theory you can. And when they're trying to bluff you off saying you can't, well, they're probably getting confused between special and general relativity. Okay, thank you.